There is an inexplicable fascination with black holes. Because of their strong gravitational attraction, these enormous, invisible, and all-consuming objects that lurk in space seem both fascinating and terrifying. They also help us better grasp the fundamental rules of physics and the functioning of our universe. A few years ago, scientists were able to create the sound of two black holes colliding for the first time, which was nearly unreal. This video, music, will teach you how this event sounds and anything else you need to know about this extraordinary cosmic occurrence. How does the sound of a black hole collision sound? Scientists detected gravitational waves produced by colliding black holes for the first time in September 2015. These waves were measured by U.S. LIGO detectors and subsequently transformed into auditory sounds. The Laser Interferometer Gravitational Wave Observatory, or LIGO for short, is a high-precision instrument designed to measure gravity waves produced by astronomical events like black hole and neutron star mergers. The detectors detect minute changes in gravitational wave frequencies by using laser beams that bounce off two highly precise mirrors. There are two detectors in the LIGO project, one in Livingston, Louisiana, and one in Hanford, Washington. Each gravitational wave created in the cosmos infinitely far from us can be recorded inside these measurements by the laser beams traveling with arms 4 kilometers long, arms by the changes they bring about in the fabric of space-time. Although this technology is really exciting, you may be wondering what it sounds like when black holes collide. The measurement produced a dull sound that is similar to the sound of water droplets hitting a solid surface. Music. A group of experts from many nations and organizations created this unusual recording, including technicians and researchers from the Massachusetts Institute of Technology, the California Institute of Technology, and the French Research Organizations CNRs. As you can see, the gravitational waves produced by the collision of two black holes are detectable even on Earth, albeit in a very narrow range. This event of extraordinary magnitude and energy forever alters the structure of space-time. Beyond the allure of this sound, the subject of why black holes collide in the first place and what transpires during the collision naturally comes up. You are undoubtedly aware that black holes are the largest and heaviest known objects in the universe. However, because these cosmic giants are made of nothing, they are extremely heavy for as yet unexplained reasons and bend space-time in such a way that extreme attraction forces create black holes. Once two black holes collide, there is no turning back. But it is not that one black hole eats and digests the other. Rather, they merge into a single, even larger black hole. In the process, enormous amounts of energy and power collide, and an event of this size generates no more noise than a few drops. Music, sound propagation in the cosmos. Sometimes you hear or read that the universe would be completely silent because sound cannot propagate in the cosmos. However, since air is the medium of sound, it is not as abundant there as it is on Earth. Big bangs and fire hisses during spaceship battles, as frequently portrayed in movies, would not be audible in space, but there are subtle transmissions of wave events. And finally, all events in the cosmos are events where waves and frequencies are generated in the vacuum of interstellar space pressure. Waves and oscillations can be transmitted by ionized gas and plasma. Far away, researchers employ the sonification process to convert celestial occurrences into auditory signals that are beyond human hearing. The scientific process of turning any type of data into audible sounds is called sonification. There are various methods for translating sounds. Assigning data values to pitches, volumes, or timbres is a popular technique. For instance, by mapping the color scale to the musical scale, the primary color values of well-known paintings could be transformed into sounds, making Da Vinci's Mona Lisa audible. Another method is to generate sounds using algorithmic patterns. For instance, a galaxy's or molecule's mathematical structure could be transformed into a series of sounds. Health truly sounds very different from a disorder. Sonification is now also employed in medical technology and particular diagnostic procedures where medical images or measured values are turned into sounds to make the results easier to interpret. Music. What other sounds do black holes produce? Of course, the intriguing question is whether black holes produce other sounds, and the answer is that they do. When matter falls into a black hole, the accretion disk surrounding it heats up, producing very little electromagnetic radiation that can be sonified into sound. To put it simply, these would be the sounds of a black hole digesting food. Naturally, waves are also produced by the giant's curvature of space-time, and they can be converted into sounds, much like practically every cosmic event. Black hole collisions validate relativity. Albert Einstein, a mathematician, first described the structure of the universe 100 years ago using formulas and equations. For Einstein, the majority of these assumptions were mathematical logic and necessity rather than proven facts. But today, general relativity serves as the foundation for our contemporary understanding of the cosmos. The interaction between matter, gravity, and space-time is explained by the theory of relativity. Nevertheless, many of its presumptions and formulas were not verified by actual space measurements until decades later. Dark stars were also included in Einstein's formulas. Later, the things that turned out to be actual black holes were referred to as totally collapsed enormous objects. Black holes are usually formed from very massive stars that collapse at the end of their lives when a star with a mass of at least 3 solar masses has used up its nuclear fuel. It can become a black hole through gravitational collapse. The collapse of the star leads to an extreme compression of matter. The remnants of the star then possess a gravitational force so strong that nothing that enters the black hole can escape from it. All these old names for black holes describe pretty well what. These phenomena are all about the discovery of gravitational waves, and black hole collisions was able to reconfirm Einstein's theory of relativity because the measurement proved that gravitational waves do exist, and they propagate at the speed of light. This is exactly what was predicted in the theory, but the confirmation goes much further, because the measured waveform also exactly matched the predictions of general relativity. This strengthens confidence in the correctness of the theory, and opened up new possibilities for observing the universe through gravitational wave detectors, why black holes have no hair. So far, everything still sounds scientific and good, but when we now come to a theorem that says black holes don't have hair, you might wonder a bit. What sounds crazy, however, has a sound scientific background. The physical no-hair theorem states that the only observable values of a black hole are its mass and angular momentum. This theorem was first formulated by physicist John Archibald Wheeler. In other words, the theorem states that the physical properties of all black holes are exactly the same. Therefore, it's impossible to distinguish one from another. This would be quite different if black holes had hair and could be distinguished by their hairstyle. However, this does not mean for sure that black holes do not have properties or signatures that are unique in our cosmos. There are so far no stars which resemble each other up to the hair on the contrary. The universe shows us an unbelievable variety of individual characteristics and seems almost like a law that no object exists exactly twice. Why should this principle stop at black holes? It's possible that giants have more qualities, that we are unable to measure, comprehend, or know what goes on inside. It's also feasible that quantum physics will soon alter. This is due to the fact that scientists have discovered that quanza inside black holes and quanta traveling beyond the event horizon into space are entangled. If we can eventually decipher the quantum information structure, we may also be able to communicate with the interior of mysterious black giants using light particles. As of right now, the only thing that is known about black holes and dark matter is that they are important components of space-time. Theories even suggest that they may be wormholes into other dimensions or parallel worlds. The only exception to this rule is Hawking radiation, which has already been briefly explained and occurs when one of two entangled quantum pairs penetrates beyond the event horizon to the outside, where objects that do not emit electromagnetic radiation, such as visible light, infrared radiation, or radio waves, cannot normally be seen with our eyes or instruments. Black holes are also not literally black. Rather, they appear black because they are unable to reflect or emit light. Black holes play a major role in the structure of space-time and the velocity of stars because they exert the highest gravitational forces in the universe that have been discovered to date. Dust and gas in space. For astronomers, every object interacts with every other object. Black holes are crucial instruments for comprehending the evolution and behavior of galaxies. The ideas of a black hole's event horizon and singularity, at its core, enable additional inferences to be made regarding cosmic events and, eventually, its genesis history. In terms of black holes, singularity is a physics notion that describes a location in space where gravity is so powerful that it becomes mathematically limitless. The singularity is a crucial and enigmatic aspect of physics. It is also thought to have been the starting point of our cosmos prior to the Big Bang. The singularity is the point at the center of the black hole where the density and curvature of space become infinite. At this point, it is currently believed that the known laws of physics no longer apply. Black giant research is still in its infancy, but physics never sleeps. Hundreds of researchers from around the world are currently working to unravel the mysteries of these space phenomena, and we will naturally share any new discoveries with you as soon as they become available. Thank you for watching. Appreciate your feedback, and we hope you had a great time. We hope to see you at Simply Space again soon.